But apart from that, creating a to-do app is actually very simple. I mean, if you go for even other languages, at least the front end projects, to-do is a very popular app that people make, right? But still iffy on slices. We'll cover that. Slices are not difficult. You can just, I think you can just go for both slices, slices, and we can go through that, go through the packages. Blog was there. Blog, yeah, this one. This is a very good intro to slices. You can go through this. If you still don't understand, I don't think you won't understand after reading this, but if you want me to give a online demo kind of a thing, I'll do that. But today, well, we won't be using a lot of slices for to-do app anyway. We will, but not much. Basically, slices are arrays that can grow dynamically, and there is a little bit of semantic around that, how you add something into a slice, and how you iterate over it. But apart from that, it's basically just like an array. Hey, Saurav Modak is here. Saurav is a long time friend. Hi, Saurav. So, okay, let's start. Do I have the project? I don't have the project. Someone complained about the size of the code last time. I hope it is good this time around. It looks big enough to me. Okay, let's create one more. I was writing something about ground. I have not committed it yet, I guess. Yes, okay. New project, and I'm just gonna call it to do. Okay. Enable vendoring support automatically. Vendoring support. I guess we should talk about it a little bit somewhere. Basically, vendoring support is like any dependencies that you have for your program, they get vendored in your program. So, for example, here it will have sorry. Here you have a vendor folder within which all your stuff will live. Okay, so we have a module. Let's call it, this time let's give it a better name. So we'll give it github.com/techtail, because this is how modules are typically supposed to be defined. You have to have a place where your code is going to be hosted. So it's GitHub, GitLab, doesn't matter where it is. It should be a Git repository typically. And let's say this to do CLI. Okay, good enough. Save it. And let's now create a new file. We'll call it main.bo. Okay. And today maybe we won't do a lot of stuff, but we will do some basics things. Right. Wait, I forgot how to read a variable on CLI, so I'll have to look at that. But let's begin. I'll search about how to. From main, we are returning one thing, and just going to say from t.printf. Printf. This is a CLI app to manage to-dos, lists. Is written in Go. Right? Let's run it. I'll add a configuration here so that it is easy to run. Let's run it. It says this. We are ready. Now, think of to do. What do you have in a to do? You have set of lists, to do lists. There can be, you know, everyday stuff list. There can be work related list. There can be like, okay, I have a list of things I need to learn, and so on and on. So you have a list of to do lists, and then you have got to dos inside of them. So we'll first go with a plain list kind of thing, and once we have that, then we are going to uh, create another like a list of to dos. So let's now it becomes a little bit difficult to say list of to do lists. So let's call it a set of to do lists. That sounds better. The lists are technically ordered. So let's create a package, new package, and packages in Go are directories. So let's give it a name of to do. This should contain a single to do kind of structure. Let's call it to do item. Okay. We are going to define what is a to do. Now we are going to use this to do in our CLI. I will write some printf scanf stuff over here, and here I am going to write some code which will refer to things inside to do package, and we'll be referring to this to do type quite a bit. So it's important that we make it exported, and as you know, exporting of a variable or a function in a package, or exporting a field in a struct, happens when you make the first character of the name capital. Obviously you can't have something like 922, and I hope everyone knows that you can't create variables and any kind of identifiers using a name that begins with a digit. So we'll have a to starts with a T, capital T, so that it is exported outside. We can refer to it, and so on. So what are the contents of to do? What are the things that you do with the to do? You obviously have a message. You can have a title and a description. Usually people just put in a title when they're in a hurry. So let's have a title, which is obviously going to be a string. And in an actual app, you have a way to restrict the amount of data that these fields contain. Okay, when you have a database, you typically are mapping these fields to a column in a database where you have a restriction that, okay, the title is going to be, say, varchar 100 characters, like should not be bigger than 100 characters, or its description cannot be more than 1000 characters, because if you're crossing 1000 characters, you're basically writing a note, and so on. But in the program, you'll have to apply those uh, validations manually. So in you can't do that right now here. You can't write varchar 30 or varchar 100 over here. So we'll just declare this a string. Okay. Then we have a description. We'll just say desk, and this is also going to be a string. A to do always has a state. Have you created it? Have you deleted it? Have you finished it? Is it not yet done? Is it half done? So let's keep it simple. When you create it, usually to dos are in a state of not yet finished. When you finish it, it's in a finished state, and that's about it, right? So we can have a state called done, not finished, done, which will be a boolean, and since booleans are by default allocated the value of false, I think we have what we need here, right? And completion date, a creation date. When did you create it? Created at, and we are going to have a time.time. Okay. We will need done or finished at. We can say updated at if you want, because you are already capturing done over here. So when was the last time you updated it? Okay, or let's get rid of this for now. We will do these things when we get into more complicated stuff. Okay, this is the basic thing. Uh, some professional programs of To-Do also give you the ability to share a To-Do, assign it to someone, and attach files and stuff like that. We are not going to do that right now. And yeah, that's basically it. So, like I said, we need to first validate things. Like if I am going to create a to-do, I probably want at least a title, right? And I don't want a description without a title. So title is mandatory. Description can be something, but title is mandatory. And at least I don't want it to be a very long string. I mean, technically, you can put in 1 GB of string over here, and that should not be allowed because that will easily overrun the memory. So we need to have some validations. So let's add a function where I am going to take a to do. Usually the in Golang, the usual thing is to give really short names. I really don't like it. So for example, people will do this, okay, and this is good for short functions, but T doesn't tell me like 2 months down the line if I come back, if I am looking, this function becomes big and I'm looking at T, I might get confused. Like, what is T? This is a simple program, but as programs get complicated, you know, we introduce more variables, and if you just keep on creating more variables with T, U, V, X, J, K, this becomes really complicated. So I have a habit of giving it a semantic name, and I'm just going to call it a to-do. Something that represents the variable, the item properly. And we are going to return whether or not it's good enough. For now, let's just have one rule, and the rule will be if the length of title, and title is of to do, so to do dot title is equal to 0, or let's say at least 5 characters. Okay, 0 is fine for now. Then we are going to say false. This is not a valid to do. Or we are going to say if length of the description to do dot description is greater than, let's say, 1,000 characters. For now, let's keep it 100. It will be easy to validate by typing stuff on terminal and checking whether this works or not. I'm going to say return false, and if nothing else, then we are going to say return return true. Okay, and that is your validate function. Now the validate function typically should not be called externally. So you can have it as a capital V so that you can call it from here, and we can leave it as it is for now. But we don't have the store yet, by the way. We'll have to implement the store from where we are going to read the to-do list, and we're going to write back to it when we add or when we change some to-dos, right? So this is validate, and I think it's good enough for now. Now I need to store one to-do. Right? So before I start entering the value and ask the user to enter value, let's check whether it's working or not. So let's create very quickly to-do, and let's fill all fields. Title is first thing to do, and the description is just checking the to do, right? done is false, created at. Now time. One of the things I like with Go is how time is defined. Time is beautifully simple in Go, but we'll get to that someday later. For now, let's just use time.now, and we can also use something like UTC or things like that, but let's keep it just time.now for now. Okay, now we need to print t, but we don't have a print function. Let's build that. So we are going to say func to do and print. Okay. And this is just going to fmt.print printf. Let's set the okay. And, let's go here. Oh, sorry. What should we put in? So whether or not it is, what's the title? Title says something, and I should actually do a \n over here. \n, and I would say title description, this space description d/n, and then I want a done or not, or created at. Sorry, I usually don't make so many mistakes, but as is known, things don't work when you are showing things to someone else. So done and /n, that's it. Right, we are going to do to-do dot title, to-do dot description, to-do dot created at, and to-do dot done. And that should be it. Go back here and we'll say t dot print. Now let's run it. Okay, I should have introduced a new line over here. So it's saying good stuff, but maybe we should change created at to look a little bit better. Like this is kind of not good, right? And we can say done yes or no. So let's modify our printer. So far, is it clear what I'm doing? This section. Yeah, when we say selective caching of dependencies, it's not selective caching, it's caching all the dependencies of your program in one place. Yes, all right. Ankit. Ankit didn't say anything. All right. Move it away so that I can read it. Okay. Okay, let's leave it as it is. In fact, I can keep it here so that I can read some comments and why not also. Okay. So we need to say done as yes or no. So if to dot done, we need to store it in a variable and then print that variable. So let's create that variable and we'll say done yes no. And we're going to say no, and if to do dot done, then we are going to update done yes no to yes. Okay. And instead of to do sort of done yes no. All right. By the way, there's an interesting thing. If I put a colon over here, it okay, you have not exactly used it, but it is actually possible to do it here. If you start using it, for example, do this. Now you see it doesn't give me an error. And do you, if I don't know if you're able to see the slight change in color for done yes no over here and over here. This is white and this is a kind of teal in color, right? So you are basically redefining done yes or no. So you, in this block, you have just overwritten this variable, not overwritten. We call it shadow the variable. You have created a shadow of the variable. Okay, and if you do this and you print over here, you'll always get no. Always, because here you are creating a new variable. But anyway, we'll do that later on. And all right, so we have got print. Let's check. It said no. Okay, it says no. And if we change it to true, sorry, should we just make this true? And if I run it now, done says yes. So we have successfully changed the word that gets displayed for the state, right? Now we should be creating, like we should be changing the, one second, what did I do? The way created ad is getting displayed. This is complicated, right? And we probably just want the year, month, date, hour, and minute. Seconds probably not very important for a to-do list app. So we can use format, and the way you do it is you have a layout string, and that layout string will contain the placeholders which will be replaced by values from the time itself. And I think most people would be familiar with this. Now the way I do it is very simple. I always remember there is a RFC 3399. Now if you go to RFC 3399, you will get this definition. You will also see there are so many other definitions, right? And it's very simple. It looks very simple, right? You have got Jan, you have got Monday, you've got 0, 2, 15, 4. And what it is doing is, if you write 2006 somewhere, anywhere for time, you see, these are all 2006. The months are always going to be 01. The day is always going to be 02. Okay. The hour is always going to be represented by 15. The minute is always 4. The second is always 5. The time zone is always 7, and so on. 06 is, by the way, year for with only 2 digits, and so on. Now this is easy to remember, kind of easy to read. You don't have to think about whether small m is for minute or big M is for minute, and you can just copy this and paste it somewhere. So I'm going to just copy this. I'll go back, and instead of saying RFC 33399, I'm going to paste this and paste it. Now I don't want the time zone, I don't want the seconds, I don't want a T over here, okay? And this is what I want. I want the year, month, date, uh, the hour and the minute. Now let's try to run it. You see, just displayed like that. You're not getting the rest of the garbage that was coming out for time. The rest of the stuff was actually time zone information and how much time has elapsed since you started the program. That plus m thing is that, and it's called the internal clock if I'm not wrong. And there are a bunch of other things that that can be shown. But we basically are interested in this. We will improve it later and look at it in a better way, like say January 02 or today's like 20 April 22nd 2024 at something. You can do all of that, but this is good enough, right? So you have got a to-do item defined, right, which can be validated and printed. Let's try to validate now. Say empty dot print if to do is valid, and I'm just gonna say wait a second, slash n, and we are going to say t dot oops, validate. Okay, obviously it's going to say a yes, sorry, true false, not yes no. This to do is valid. Sorry, is valid over here. Lovely. Let's read title and say, and I am just going to let's put a lot of stuff here. Okay, I hope it's a big string enough. And I run it and says to do is valid, false. And this is why you return errors. Might be kind of off topic, but is there something in Go equivalent to templates in JSF strings in Python? Is sprintf the only way? There are templates in Go, but they are used in a very different way. They are used mostly for HTML rendering. Okay, and you probably don't want to bring in templates for this. Typically, we just use sprintf. Go is simple. Remember, it tries to do one thing in one way, and that's it. You basically have, if you have got two ways of doing one thing, there has to be a good reason, good enough reason why it's being done that way. Okay, and you can't expect all of the bells and whistles in Go. So I have at least never seen a template string in Go like it is present in JS. I hate such strings at times. The first time I encountered it was on C# and I loved it, but then I programmed for like what 7 days and it started like giving me headaches. I like simple stuff. Okay, to do is valid, false. But we have got two reasons. Was the title empty or was the description too big? Why is it false? If I put in something over here and I run it again, it says to do is valid, false. So was it, usually when you are processing something, you don't declare it literally like I have done here, right? You'll get this value from somewhere, it's coming from a file, from a database, somewhere, from a user input, and you just say what, take the variable and run validate, and it gives you a answer that says false. Are you going to tell your user, dude, something is wrong, please fix it, without telling the user what to fix? So this is where errors are important, and this is why we return errors instead of booleans normally. So here what we need to do is we need to tell whether or not your to do is valid, and if not, then what is wrong. Okay, and let's change it to error. We are going to return errors, and I am going to say fmt.errorf, or we can use errors.new for this one. Errors.new, and say title is empty. Okay. Basically, it is crying because my T is, sorry, capital. And if I replace it with T, you'll see the errors that. And this is basically not Golang complaining, it's my IDE complaining. It says string should not be capitalized or end with a punctuation mark. And this is because of the way Go's coding guidelines are. They're guidelines, they're not rules, so you can break them, and it's actually better to keep it small. Because what happens is, I'll probably be putting an error message here, right? And if I say to do is not valid, error colon, and then I start writing something else, a capital T is not going to look good. This is why we basically have small case, errors starting with small cases. This doesn't always work. IDs are not always going to give you errors, depends on what kind of function you are using, how you're building up your error, and so on. But anyway, let's create another one here. Errors.new, and we say description is too long. Okay, and in case there's nothing wrong, then we are going to return a nil error. Remember, error is an interface, and interface by default can has the value of nil. Any type that you declare as an interface, default zero value is nil. So you can easily return nil over here. Makes sense. You don't have an error, so you're not going to return an error. All right, let's run it. And what does it say? Title is empty. Now if I put in a title, first to ever, and now if I run it, the description is too long, right? And if I reduce it, say I deleted it and said just testing the app, okay. And we're going to, this doesn't look good, right? Which is why we do things like, if t dot validate is not equal to nil, then do something, or don't do something. I mean, you can have an else. You can say fmt dot printf something like to do is valid. Now we should update it to is not valid. Error is this. Now if you run it, say to do is valid, right? So we have used some of the understanding we gained with Go, and we have implemented it here. And you can see how it is working, right? Everything clear so far? Looks like nobody's ready to type in. Okay, I'm going to assume everyone got what I was explaining. All right. So now we need to store it, right? We need to store it. So I said in the where is the outline? saving the data of to-do app to a JSON file, and we'll get to the CLI writing a little bit later. So this part I told you like what we want to do with the app, and the things that we are doing and things we are not doing. Like we are not doing attachment, we are not doing allocations to like assignments of a to someone else. We are not exactly starting off with a web UI or so, something like that. Simple CLI stuff. And this part I'm going to talk about why JSON file. So the reason I'm starting off with JSON file is because JSON is kind of universal, and you're going to use JSON in your web APIs when you build them. You are going to encounter JSON in a lot of other places. I think practically every communication that is happening between a client and a server, except maybe inter-service communications happening inside a cluster, which has shifted to gRPC mostly. We all use just JSON everywhere. JSON is easy enough to read, easy enough to write, and it's compact. It can be like it can be expanded to look beautiful, or it can be compacted to look like ugly but very efficient for network. Like, it reduces the size, the amount of data that gets transferred. We don't have to transfer all the indentations and spaces and whatnot, right? So JSON is something you're going to encounter every now and then, and that is why we are going to store it in JSON. That is one reason. The other reason is I am going to basically go ahead and update the to-do app, I think somewhere here. Okay, we will replace the JSON file with a SQLite database later on. Maybe I'll just replace it with Postgres in the get-go, but that will basically demonstrate how we can use interfaces to actually have two storage modules. Like you can say, okay, my CLI app, you can write a config module, config file, and you can tell your app that, okay, please use a database, and this is the connection in string, or this is the SQLite file which you have to use. Or you can say, please use the JSON file to store everything. That way, the app and the your data stays portable and whatnot, and it's just easy to work with. I know that we'll probably not be using this CLI app to actually manage our to-dos. That's not what it's being built for, but it's good enough to start and show what we can do with Golang. These are the basic stuff, right? So we are going to convert it to JSON, and we are going to store it, right? So before we go to the file input output and how we are going to do it, I have forgotten how we do it, so I'll basically search and figure out. But before we get to that, let's first try to encode it into JSON and see how it comes out. Okay, so the way to and I always forget which is what. There are two very confusing words that Go has got. I don't know why they were chosen. It's marshalling and unmarshalling. I think it is encode and decode. That's how I try to think, and then I have to like mentally compute what it means. So we are going to say a JSON.marshal. Okay, it's going to give me a byte. Marshal. We are going to, it was called T, right? So Marshal, and we have got any, so T will be accepted. And it should give me a byte and error. Yes, it gives you a byte and error. I think if you install the VS Code extension for Go, you'll also get these kind of tips. Like I don't know what to call this window, this hint window about this method signature. So I'm gonna have to create two variables to store the bytes that I receive and the error. So let's say I'm gonna call it to do bytes and err, and this is it. And we are going to say if err is not equal to nil and nil, then I'm gonna throw an error. Okay, d.f something went wrong encoding to JSON. JSON. Creator of JSON wanted it to be pronounced as JSON. You might have heard, if you any of you watched the Primogen, he pronounces it like that. I think he's just trying to respect the person who created JSON, and I don't know, maybe he's just making fun. He's a funny guy. And we are going to say earth, and let's see what those bytes are. Printf and JSON encoded. Sorry, I can't pronounce it JSON. It's too used to JSON. I'm sorry if that makes you imagine Jason Bourne or Matt Damon, but I'm just gonna call it JSON, and we will print the value, which is to do bytes. So what do you think will be the output? You are going to see the bytes, and they look like this. I'm just going to disable it, it's a little bit distracting, and run it. And what you are seeing is raw bytes. Okay, is bytes just ASCII value array of each character exactly. So you see 123 and 125, right? What's 123 and 125? ASCII chart. Let's open something. 123 is opening braces. What happened? Okay. This is really looking bad. Let's go to images. Maybe like a large one. Okay, maybe this looks good. Open this. Just open image, new tab. Yeah, 123 is opening brace and 25 is closing brace. If you go back, it's starting with an opening brace and it's ending with a closing brace. Right. And the best way to convert a set of bytes to string, it's very simple, and this is how you do typecasting. And you will say JSON bytes over here, and you can say JSON string over here, and you just have to say convert it to string please, Mr. Golan, and it will do it. And you can similarly take a string and convert it to do bytes, bytes by using bytes slice notation. Okay, see, you have your JSON string, right? See, 34th is a code character, I think, yeah. And then you have got T, which is this. So the good thing with this presentation, and I love it, is that it's never going to crash your terminal. You have to understand that when you send some command or terminal, if you have a terminal over here, and I say, let's say something like here, and I press Control A, it goes back. And if I press Control E, it goes to the end. Because these are cursor movement commands. But there is some data that got transferred from your operating system, I mean your keyboard to your operating system, and from your operating system to your this terminal familiarity, right? And there was some data that got transferred and got interpreted by the terminal to as a command to do something. So if you have, I don't know how many of you have encountered this, but sometimes when you're trying to just dump some binary data onto your terminal, that binary data might contain some characters which will be interpreted as control codes by the terminal emulator and will do stuff that you did not intend to do. I have actually lost data in that process. I don't know what was the file. I don't remember what file it was, but I dumped some file. I tried to cat it, right? So if I say, I think DSS store is itself a binary file. So if I say cat.ds store, see, some garbage. Why do we have this here and this here? Because there are control codes that are making things happen, right? I don't know the format of DSO to make a lot of comments, but this is garbage, right? With this notation, you will never encounter that problem. If you print your bytes in Go, you're never going to get some kind of a garbage that will send control codes to your terminal and crash the app, delete a file, and whatnot. So this is a very brilliant way of dumping bytes, and it also just lets you analyze what was there without having to use a hex editor per se. I mean, this is not a very friendly representation of your data, but it is much better than having that garbage that I just showed you. I mean, this is eons better than this, right? Sorry. So this is a string to do bytes, and let's do one thing. Let's allocate it to a variable and say to do JSON string, and we are just going to say a string to do bytes. Okay, and instead of putting this here, I'm just gonna say to do JSON string, and it will give you the same result. Okay, and now you can actually convert the string back to bytes using to do let's just no. Go back here and say bytes, and page say bytes is just a slice of byte. Please convert what I'm giving to a slice of bytes, and I'm just going to give it the to do JSON string, and what you'll get is exactly this. Okay, it didn't change this part, so you can see this, and let me make it a little bit bigger. You'll get the exact same stuff. That's how you convert from a byte slice to a string, and from a string to byte slice. And while this doesn't look good, and you should probably be converting your outputs from any function that gives you bytes only when you have to display it, because as you work with Go, you'll notice that it deals with a byte slice way too much. Oh God, I got a call. And yeah, so that's done. Now if you let's get rid of this stuff and just print this, because that's useful to us. Like, do you notice something? It came up as title with a capital T, description with a capital S, description desk with a capital D, done is also capital D, created at is this, and since we didn't specify what format to use, it just dumped whatever it felt good, which is, I think this is RSA 3339 or one of those. So well, okay, we can work with this a little bit later, but usually when you're sending some JSON over the internet or to your app and back and forth, you won't be using this format, right? You want to make it like this, and your created at is supposed to look like this, right? Let's call it, sorry, title is here, and do we have something more? Okay, this is title and this is created at, so I would say created at this, right? But there is a problem now, and as I type T over here, you will see it is not accessible. Because now these folks are in lowercase. So when you go to To-Do app, this is not exported. If you try to run it, Go will give you an error. It doesn't know unknown field title. Here in main.go, you have this to-do in this package and it's not exported. I mean, this type is exported, but the field title inside the to-do type is not exported. So outside of this package, this to-do package, here in the main function, you don't have access to the title. So how are you going to print it ever in any, you know, representation other than the default one? I mean, you can't keep on using capital letters everywhere, right? You might want some underscores, you might have spaces in your JSON keys. So let's undo what we have done and introduce you to the concept of tags. These are called tags. The way tags are written is this, okay? And this is basically the IDE doing it, but you create a tag. I mean, this is a tag list technically. Inside that, you have the type of tag, the name of that tag, and the value of that tag. Okay, and this is very important because and it makes things really simple. How? So maybe when you implement it in a database, you want this title might be having a field name, I mean, might be corresponding to the column name of name, okay, or let's say heading or main title or something like that. So when you do this, if your database package, whatever driver is basically interacting with your database, has implemented the db tag, then you can just say db colon the column name, and without having to write a separate function that helps your program or your driver read this field from your database, you have done it. You don't have to write that function. You just have to specify the tag and the rest of the work will be done for you. And while we'll get to this when we get to the DB side, we can just use this. So if I now run the program, you'll find the title becomes small case. I can have it title for to do, it can be widely different, something here, right? See, not the space. Okay, so this is how you do tags. So let's create more tags, make it look beautiful, and JSON is done. JSON created add, looks good enough. And if you run GoFMT, either via terminal, via your ID, whatever, I'm just going to press Control S. It's going to arrange your code beautifully like this. I mean, even if I want to make it look ugly, I technically can. Like, I can try doing this. The moment I press Command S or Control S for Windows or Linux, it will arrange it. It looks beautiful. But if you have multiple tags, those tags don't get aligned automatically. So that doesn't work inside the tag string. So you have got a to-do structure. You know now how to write a function for validation. We have done a print. We have done changes to it. We have printed it. We have learned how to do JSON marshalling. How to convert bytes to string and string to bytes back again. And I think this is good progress. Are you guys getting it? I mean, we are already at 8:10 p.m. I mean, I can go on. I don't have a problem, but I think we should keep the videos on YouTube a little bit shorter, right? Because we're not covering a lot of ground every session. So anyone who is watching doesn't have to feel like they have to watch for too long.